All right, so you got a Ferris wheel, radius is 8. Okay, so if the radius is 8, which one of these quantities do we automatically know? Angel, if the radius is 8, which one of the amplitude, the frequency, the phase shift, or the vertical shift do I automatically know from the radius? The amplitude. So this, I don't have to divide it by 2 because it's the radius. So that's automatically A. So I know this is going to be 8. So this is an 8. This is an 8. Okay. If the, let's see, the period is 48 seconds. So I can use that to get B. So 48, that's the period, 2 pi divided by B. And now solve that for B. 48B equals 2 pi and divide by 48. All right, and we get B is pi over 22. Okay, so I can put that right here. Okay, so now next up is the phase shift, the slide. All right, so to do that, we got to graph this thing. So just like you did yesterday, you got to figure out what the high point is, what the midline is, and what the low point is. Okay. So let's see, we're told that the center axle is 10 meters above the ground. So that was automatically vertical shift. So the height of the center of the Ferris wheel is automatically the vertical shift. So we can add those in. Now all we need is that value of C. Okay. All right, so this is 10. So we know that's our midline. Okay, the radius is 8. All right, so Chase, what would be the maximum height? How much? Yeah, I'd add 8, and I'd get 8. So let's see, 10 2, 4, 6, 8, 10. 10, 12, 14, 16. I got to fudge it a little bit. 18. All right. And JC, how about the low point, the minimum? Yep. Subtract 10. All right, now I'm going to take that period and divide it into 4 parts. So 48 divided by 4, that's going to be 12. So every 12 seconds, the graph is going to be, my location is going to change. So if you kind of estimate where 12 seconds is, then 24 seconds, I'm just kind of estimating where they are. And then 36 seconds, see, this would be 35, so 36. 12, 24, 36, and then 3. And then it's just going to repeat after that. All right, so we want to draw this graph. So at 0 seconds, Isaiah, what's my height? I get on down here. It's going to be 2. So 0, 2 is my first dot. Okay, 12 seconds, Jose. So I'm going, now I'm there. Yep. So at 12 seconds, 10. Okay. 24 seconds, 1. Okay, 36 seconds. John, back. I'm sorry. I'm sorry, I can't. And then at 48 seconds, I'm back down to 2. And then it's just going to repeat again. 10, 18, 10, 2. Okay, so my graph looks something like this. And then I could keep repeating that. Okay, now here's how you do your phase shift. If I was doing a normal sine curve, and this is the part where you gotta just watch how I do it. A normal sine curve, guys, starts at the midline, goes to its max, goes to its min, goes to its minimum, then goes back. So a normal sine curve would be doing something like that. So now, to get the two maxes to match up, I got to take that black curve and slide it to the right. How far did I slide it? How many seconds is that? This max is at 12 seconds, and I slide it over. What's the new max? Right, so how far did I move it? Yeah, 12 seconds to the right. So C equals 12 seconds. All right, now when you write it in here, you could just write in 12. Now, I need everybody to look up front. I wrote it right here, phase shift. Phase shift. Okay, now look at over here. I'll change the color. I put the 12 right there. Now, when I do it on the next one, I can't put 12 in there. Okay, when it's written like this, I have to get that value, I got to take the phase shift and I have to divide it by the value of B. This is C divided by B. So that would be 12 times, oh, wait a minute, wait a minute. Divide by C divided by B. Distribute. Yeah. So this would be pi over 2, C divided by B times pi. It's not right. Wait a minute. Say it again. Yeah, I should be getting up. Yeah, I should be getting pi over. Yeah, that's right. C times. Yep. Pi over 24 times 12. 12 pi over 4, which is pi over. All right. Okay, then you're going to graph that. Okay, so open up a file, open up a Desmos file, and we're going to type in this table here. So the table. Okay, type in your numbers. So that table here is what I'm going to put in. X is the time, Y is the height. Wrong object. Colton, can you get the lights, please? Okay, and there's my graph. And now I just type in my regression equation. So y1 squiggle a sine b x1 minus c plus b x1 y. Oh, here we go. And then those numbers are what I'm going to make my equation out of. Over here. Yeah. Yeah, to do the chart, just hit the plus sign and pick table. Yep. All right, so my equation here is y1 is 8. B is 0.13. And that's your regression equation. Okay, now to get the other one, I could just type that one in. So y1 squiggle y1 squiggle and then I'm going to use those values to get, notice everything's the same except for the C. It's just a different format. Then I'd copy that one down. Okay, then to answer questions with them. Okay, what is the height of the passenger when you've been on the wheel for 65 seconds? So that's the X value is 65. So I go to Desmos and I'm going to type in X equals 65 and see where it touches the graph. X equals 65. So the X coordinate is the time and the Y coordinate is the height. So this would be 14.87 feet, meters, whatever. So I just drew a line at where 65 was right here. Found the Y coordinate. All right, and then the last one was approximate the number of times that you're at 4 meters. So now you type in the line Y equals 4 and see where it crosses your graph. Oh, Y equals. So on the first revolution, 5.7 seconds, or okay, about 5.6 seconds. That's my first answer. Okay, 5.6 seconds. Okay, then the next time they cross is right here, 42.4 seconds. Let's see, one rotation is 48 seconds. So this would be at these two times, because the next time I hit it, it's going to be after 48 seconds. So the number of times during the rotation is 2 times during the rotation. And it happens at 5.6 seconds and 42.4. Okay, guys, we'll stop there. Tomorrow, tides. No, I got them. I got them.